we're gonna try to generate a function that gonna return us a specific number in the Fibonacci sequence, because this is a question that is often asked in the interviews that you're gonna take part in. So we're gonna try to solve this exercise together. Okay, so in your screen, on your screen, there's the Fibonacci sequences. So Fibonacci is going to start with a number 0, so we denoted F0 to be 0. And then we're going to start with F1 equal to 1. So Fibonacci, the second element is going to be 1. And we're going to make recursion from this point on. Is that any following elements going to be the sum of the two previous elements, okay? So F of n gonna be f of n minus 1 plus f of n minus 2. So the third element, any element will be the sum of the two previous elements. So that's the idea for the Fibonacci sequences. So let's try some calculation that gonna lead so we can validate this idea. So let's calculate. You don't have F0 and F1, so let's try to calculate F2. So F2 gonna be equal to f of 2 minus 1 and plus f of 2 minus 2, right? Okay, so that's F1 plus F0. So that's 1 plus 0, and that's 1. So that's why here the third element F2 we have is 1 here. So let's try another case, F3. So we apply the same formula here. So gonna be 3 minus 1 plus 3 minus 2, right? So that's F2 plus F1. So that is 1 plus 1, and that's 2. Okay, so it's 2 right here. The fourth element is 2. Okay, so let's try another one. So that's F3. Let's try F4. F4 gonna be equal to f of 4 minus 1 plus f of 4 minus 2 minus 2. So that's F3 plus F2. So that's is 2 plus 1. That's 3. So that's so on and so on. So with that idea in mind, I want to create a program that actually when we input into n okay, so I want to create a program that is when we input n, the program gonna just generate for us fn, right? So when we input n in, I want the program to return for me fn, right? Fn. So that's the idea of this this program, okay? And we're gonna try to implement it. Okay, so for these exercises, first of all, we're gonna create a function. So def print Fibonacci. We're gonna call our function print Fibonacci because we want it to return Fibonacci numbers. So and we're gonna to let Fibonacci, okay, to let the function to receive a parameter which is the index of the number that we want it to return, okay, which is number n. So is n, okay. for example, when n is equal to 0, you want it to return 0, right? And n equal to 1, you want to return 1. N equal to 2, we want to return also 1. N equal to 3, we want to return 2, okay? As we have calculated here. Okay. So first of all, I want to create an empty list to store variable. Okay. So now you can see here. Oh, no, I don't need a list. Sorry. So now you can see here. When n is equal to 1, so if n equal to 1, then to 0, so is the number equal to 0, then we should return 0, right? Because the 0 element, the f0 element of the list is 0, so return 0, okay? And we also want to have a prompt, so f0 is equal to 0, okay? Alright, so and then now if n is equal to 1, okay, so that's comparison side, sorry, then we want it to return 1, right? So same thing, f1, and we're gonna return 1. Okay. Alright. Now so it's if here, it's if here because it's second condition. So now we can come to the Fibonacci algorithm. We know that any of these third term gonna be the sum of these two previous terms, right? As you can see here. No. As you can see here, the sum, any third term is the sum of its two previous terms. So fn is fn minus 1 plus fn minus 2, which means any third term is the sum of its two leading terms. Alright? So else we're gonna return, okay, so print Fibonacci, so we call the function again, n minus 2 and plus print Fibonacci n minus 1, which is the two previous term of print Fibonacci number n. And let's check it out. So print Fibonacci 0, and let's test for the second guy, which is 1. Okay, the third guy, which is 1 again, is 2. Okay, so it's 2, so we want to print out the second element, and we also want to print out the third and the fourth element, 3 and 4. Alright, so for the print Fibonacci number 0, we want it to return 0. Or print Fibonacci number 1, we want it to return 1. And for number 2, we also want to return 1 because 0 plus 1 is 1. And for number 3, we want it to return 2. And for number 4, we want it to return 3. So I want to make a 6 statement, so it could return the 5th element, which is 5. Okay, so that's our expected result. So let's test it out. So run. Okay, so I gonna delete this. So we don't have any arrow here. So 0 0, yes. So sorry, 0 0 1 2 0 1 1 2 3 5. So that's just what we expected it to return. So this algorithm of us is actually correct. Okay. So that's the algorithms for you. So the basic idea is just that we define the first two elements, uh, Fibonacci number 0 and Fibonacci number 1, and then any succeeding term is going to be the sum of these two uh, preceding terms. Okay, so that's algorithm for Fibonacci numbers. Okay, so we also want to because that's a recursive algorithms, right? Because we only we always has to trace back to what is the previous number is, so it's a recursion algorithms. So but also Fibonacci sequence has a very interesting uh, interesting properties is that you can generate the number as a pair of input and output functions. So there actually a straightforward formula for Fibonacci number, which is closed form expression that any Fibonacci number can be calculated by the number. This I don't know what is called. Is sigma or phi? I think it's called phi, right? So uh, it's phi, right? Phi. It's phi. So the Fibonacci number can be calculated by phi to power n. You know, it's the index of that number minus psi to power n, and all of that divided by square root of phi. So that's the formula for individuals Fibonacci number. So Fn is uh, is so any Fn is just phi to power n minus psi to power n, and all divided by square root of phi. So that's what we have here. So we're gonna have the same print Fibonacci function, and we're gonna define phi to be 1 plus square root of phi divided by 2, and also psi is 1 minus square root of phi divided by 2, and then we want to return the Fibonacci number which is phi to power n minus psi to power n and minus phi over psi, which is just square root of 2 5, just square root of 5. So that's why we can use a formula for generating Fibonacci sequences. So we have to make the int part here for the formula for the formulas, because otherwise because we are dealing with square root, so otherwise even though the real answer going to be an integers, the software going to return a float for us with a float with a decimal part of 0.0 or some 99999, which I don't want to make it like a erroneous like that. So we fix the data type to be int. So we just also have to import math library to use the square root functions. Okay, so let's check it out. So so we haven't saved this one. So file, save, and we run. So 0 and 1. So let's let's keep going with the test. In this case we test to the fifth element. So let's check, do the same thing here to see if we generate the similar series. So this is 3, this is 4, this is 5. So here we expect 0 for the second element. which is f no, which is f1, expect 1, f2 is 1 also, right, okay, f3 is 2, f4 is 3, right, and f5 is 5, right. So that's just our expectation. Let's check it out. So 0, 1, 1, 2, 3, and 5. So that is actually correct. So that's the program to find Fibonacci numbers. So and dealing with Fibonacci sequence. So thank you very much for attending. Have a good day. Goodbye.